Welcome to video lesson 2 on rationalizing radical expressions. What to do when the denominator is a binomial. There are two terms. Most of the process is the same. You still have to reduce coefficients, you still have to reduce radicals, you still have to multiply the top and the bottom by something to get rid of the radical in the denominator. However, to get rid of the radical, if you have a binomial, you have to use a slightly different process here. You have to multiply the top and the bottom by something called the conjugate. The conjugate is an expression that has the same two terms but with opposite signs. I'll show you what I mean by that. If you had to simplify an expression like this, there is a radical at the bottom, but now the radical is part of a binomial. There are two terms separated by a plus or a minus. We'll go through the first couple of steps. The coefficients here, 2, 3, and 2, 1, cannot be reduced. They don't all have a common factor. The radicals, neither one can be reduced. So we move on to step 3. There is a radical in the denominator, and it's a binomial. Here's what you do. Multiply the top and the bottom by this. Notice that these two denominators have the same two terms, 3 root 2, 3 root 2. The only difference between them is that this had a plus and this has a minus. That's what the conjugate is. The sign between the two terms of the denominator is different. I multiply both the top and the bottom by that same conjugate. The top and the bottom of what you multiply by always have to be the same no matter what. Okay, now that I've got that, I multiply. And remember that when you're multiplying by a binomial, it's as if it's in brackets, and it means that you have to distribute. It means that I'm going to multiply 2 root 5 times 3, becomes 6 root 5, and 2 root 5 times negative root 2. That becomes negative 2 root 10. And at the bottom, I have to double distribute. 3 times 3, 3 times negative root 2, root 2 times 3, and root 2 times negative root 2 becomes negative, and root 2 times root 2 is just 2. The reason that this works, this process of multiplying by the conjugate, is because I still have radicals in the denominator, but they cancel out. I've got a negative 3 root 2 and a positive 3 root 2. And when I group the like terms, these cancel out. And I'm left with 9 minus 2 at the denominator, that's 7. Because neither one of these is reducible, I'm done. That's the final answer. We'll do one more example. This one happens to have a binomial on top as well, but it doesn't change the process. We would reduce the coefficients if we could. Here we can't. We'd reduce the radicals if we could. Here we can't. And because we have radicals at the bottom and we have a binomial, we use the conjugate process. We multiply the top and the bottom by the conjugate of this term. That means the same two terms, root 2 and root 7, but instead of a minus between them, a plus. I'll multiply the top and the bottom by the same thing, and I'll have to double distribute both. So I'll have to multiply negative 2 times root 2, negative 2 times root 7. 2 root 3 times root 2, 2 root 3 times root 7 on top, and I'll have to double distribute the bottom as well. This is what I get. For the denominator, I'd end up with root 2 times root 2, we know is just 2, root 14, negative root 14, and negative root 7 times root 7 is just negative 7. So again, notice that using the conjugate process, the root 14 and the negative root 14 will cancel out. We'll be left with 2 minus 7 at the denominator, which is negative 5. None of these terms up on top are reducible, so that's it. That's our final answer, and that's the end of the video lesson.